It's day 2, lesson 2 of chapter 2. And what are we doing? Solving two-step equations. We'll either be using two inverse operations to isolate the variable, or we may need to combine some like terms and then use one inverse operation. Here are just a couple of examples. We'll start this first one by subtracting 3 on both sides. I have 2x is equal to 12. I'll use that division property of equality and I'll divide, that's my inverse operation, to isolate my variable, and I get a solution of x equals 6. Let's do a check. 2 times 6 is 12. 12 plus 3 is 15. You see that it checks. Second problem involves combining like terms. I now have 7x is equal to a negative 21. I'll divide by 7. We know that when the signs are unlike, we'll get a negative quotient. X is equal to negative 3. Our next problem starts off with subtracting 5 on both sides. I'm left with a fraction coefficient 1/2 x is equal to 13. We know if there's a fraction, we can multiply by its reciprocal on both sides. Again, keeping the equality. It cancels on the left, and I have x is equal to 26. If you're not sure if your answer is correct or you have time, you check it. 1/2 of 26 is 13. 13 plus 5 is 18. Fourth one looks slightly different. There's an expression divided by 3. We'll start by dividing both sides by 3. I now cancel my 3's on the left, leaving me with x minus 7 is equal to a negative 36. I now need to add 7 to both sides. When I add 7 to both sides, remember now my signs are unlike, so I then subtract and keep the sign of the greater absolute value, and I am going to get x is equal to a negative 29. One more problem on this slide. I see that I'm going to be subtracting 8 on both sides. So I have a negative x is equal to negative 5. We're not solving for negative x, so I have two options. I could either use the property of opposites that says I can multiply by negative 1 on both sides to eliminate that negative, or just divide by negative 1 on both sides. Either one works. And it just changes my signs on both sides. X is equal to 5. If I wanted to do a check on that one, well, this is the opposite of x. I'll write that original equation. The opposite of x, well, if x is 5, the opposite of that is going to be a negative 5 plus 8. Well, negative 5 plus 8 definitely gives me 3, so it does check. I have one more problem I want to look at, and this one is one that I'm going to use a two-column method and showing my transformations. I've done this before, and the reason why I'm doing this is so that you can see and be able to identify each step along the way in a written form. Sometimes you'll be asked to explain a problem step by step. This also is good practice for the setup of a two-column proof in geometry next year. 5 equals 5m minus 23 plus 2m. My first step is going to use the commutative property of addition. I'm going to relocate and just move these two terms from one space to another. Why did I do that? So I can now easily combine like terms. 5m plus 2m is 7m. I now will then add 23 to both sides. Again, my goal is to get m by itself using inverse operations and my properties of equality. I then simplify. I have 7m, and then that 5 plus 23 gives me the 28. I then have one more step to get a coefficient of 1. I will divide both sides by 7. I then have m is equal to 4. And that is my solution. If I take this number once again and plug it in everywhere there's an m, replace it with 4, and do the math, everything should work out. So those were some problems on the two-step. And again, not adding anything new probably to what you've already done in the past. Sneak preview of next lesson, the multi-steps. We might find ourselves combining like terms, doing some distribution, solving equations containing fractions as well as decimals. So until next class, have a nice day.